Hi everyone, my name is Sameh Shammoud, a PhD student teaching and research assistant at the University of Auckland and a member of the Future Cities Research Hub. This paper is titled Understanding Resilience in the Built Environment, Going Beyond Disaster Mitigation, and it's part of my PhD thesis supervised by Dr. Paula Borim from the University of Auckland School of Architecture and Planning and Dr. Sandika Manakara from the University of Auckland Faculty of Engineering, Department of Civil and Environmental Engineering. There are many definitions for resilience, yes, but there is no universally accepted one yet. Many scholars define the concept of resilience in the built environment with a particular focus on disaster resilience, such as natural disaster challenges. In contrast, others emphasize stresses that disturb the normal life in cities. This paper aims to provide a blanket resilience understanding of the entire built environment that refers to all man-made stocks, including cities, infrastructure, neighborhoods, down to buildings. The paper is mainly based on literature review, supported by word frequency method, where it used the software NVivo 12 to analyze 100 definitions of resilience. Those definitions were found in Science Direct, Scopus, and Google Scholar, and we used key resources, the following 5 key resources that helped us finding more relevant resources that include definitions of resilience. And as you can see in the figure that 59% of the definitions were actually published between 2011 and 2020, while 32% come from publications between 2000 and 2010, and therefore this indicates the increasing attention to defining resilience in academia, industry, and policy, especially in the last 2 decades. Resilience is a broad concept with various definitions and applications across several academic fields. The idea of resilience has roots in physics, mathematics, where it refers to the capacity of systems or materials to recover their shapes following disturbance. Resilience was first defined and discussed in ecology, psychology, and then was applied to many other fields such as society's engineering systems, organizations, and biology. This table shows a selected range of definitions taken from different levels of analysis, let's say, from physical, ecological systems, individual, social, communities, urban infrastructure to city systems, and down to the scale of buildings, where you can see the definitions of the US Green Building Council for resilience in buildings. This figure shows the 30 most frequent words in the 100 definitions of resilience that were analyzed in this paper. And by looking at this figure, we can come up with some conclusions. First, or reflections, let's say. 6 terms may refer to social ecological systems, which are communities, city, structures, climate, urban, and socio. This socio-ecological approach of resilience deals with the recovery process as a unique opportunity for innovation to transform the previous state of the system to a new system with new goals and objectives. 5 words may refer to verbs that express a reaction which are adapt, recover, observe, withstand, respond, and maintain. 7 other words refer to something negative happening, an action that requires a reaction, which are stresses, shocks, disturbance, disaster, hazards, events, and disruption. Most definitions do not actually refer to something that happens suddenly anymore, like a shock or a disaster. Rather, the word stress has been used slightly more than the word shock, which was not the case when the concept of resilience emerged in the built environment context in the 2000 and 2010 decade. 2 other words refer to being able to do something, which are ability and capacity, where the word ability is the top used term and capacity is Fifth, two other words refer to the need for action to change the current state to a new state, which is change and transform. And this highlights the importance of changing something in the built environment system to be able, or which is opposite to the structural engineering resilience approach that restores the system to its original state. Therefore, this approach may not apply to the built environment as it is not used in the urban-related literature. Other words refer to performance in regards to time and efficiency, which are effectively and quickly, these two words, indicating that what makes a built environment more resilient than another one is how quick and effective it can adapt or recover to reach the new resilient state. This figure gives a visual representation of the relationship between the most common keywords extracted from the definitions analyzed in this paper. The diagram is divided into two main sides, represented by two angled bold lines. The right side represents the terms used in the scenario of the ongoing stresses, while the left side shows the terms used in the scenario of the sudden shocks. So, there is a particular built environment that might have more shocks than stresses or more stresses than shocks. To make the diagram clearer, by using the terms in the figure, let us imagine an adverse event occurs in a particular built environment. This adverse event could be called a shock. Now we are talking about the left side of the diagram. As it may occur unexpectedly. If this shock is intense to a certain level, depends on the context, it could be called disaster. The affected built environment needs to observe this shock and respond in a certain way to be able to survive. And after the disaster ends, the built environment area will need to recover. On the other hand, if we look at the right side, now let us imagine that a specific built environment is suffering from chronic stresses, and this kind of challenge can add chronic burdens to the city functions. Therefore, addressing these stresses will improve the capacity of this specific built environment to maintain its services. Particular changes might be required to adapt to these stresses and achieve resilience in the built environment. After adaptation process, the specific stresses will have less impact on the built environment and it would then be more resilient. Combining both approaches seem to be more applicable to the context of a built environment nowadays, as it is exposed to both everyday stresses and unexpected adverse events. In conclusion, the findings highlight that the resilience of the built environment is not necessarily associated only with its vulnerability to standing against disasters. The resilience concept goes far beyond disaster resilience towards the capacity of the built environment to withstand and adapt with both stresses and shocks facing it. For a shock, it includes observing it, respond in a way that ensures quick and effective survival and recovery physically, socially, and environmentally. For stress, a resilient built environment is able to change in a way that ensures adapting with stress and maintaining all functions effectively without impacting the social, physical, environmental, and climatic state of the built environment. Another highlight from the result is that resilience is a context-specific approach. And that means that defining the resilience of the built environment would differ from one area to another, particularly in the kinds of challenges the built environment is facing. This includes, for example, it is a stress-based resilience in the case of the built environment facing more stresses, challenges than shocks, or is it a shock-based resilience? In general, both stresses and shocks should be taken into account when developing a blanket resilience definitions of the entire built environment. Here you can see many of the stresses and shocks that are affecting the built environment we are living in, such as the water scarcity, traffic, population increase, climate change, and energy shortage. And addressing all these challenges and even more will help in defining a more holistic approach to resilience in the built environment. Thank you for listening.